Hi everyone, I'm Daniel at QNAP, and I'm here to talk about our improved snapshot features with QTS 4.3.5. I'm also going to go into the details of how our snapshot works. So for our agenda today, we'll talk about the advantage of snapshots, how QNAP snapshots work, how to use snapshots, new snapshot features with QTS 4.3.5, and Snapshot Replica and some new features there. So one big advantage of snapshots is that QNAP snapshots have a much faster recovery time compared to complete backups. So we did a survey, or someone did a survey of about 300 enterprise and SMB companies. About 50% of them expected recovery time should be within 1 hour, but about 50% experienced actual recovery time of more than 1 day. That's a big difference, and you could lose a lot of productivity when recovery time is more than a day. So what snapshots have an advantage is a much faster recovery time. When it takes a day to recover from a complete backup, it might take 30 minutes to recover from a snapshot. Another advantage is snapshots are very space efficient. They take much less space. And in my experience, hundreds of snapshots will take less space than one complete backup. So you can afford to hold a lot more snapshots than backups. You can have a lot more versions. Also, it takes a lot less time to take a snapshot. It should, with QNAP, take a couple seconds to take a snapshot. So let's get into how our snapshots actually work. So this is a picture of how they work. So this is a picture. And in this picture, it shows our snapshot feature, which is a redirect on write. And the first thing to understand with snapshots is that files are made out of blocks. So imagine that blocks A, B, C, D, and E make up a file. And when you take a snapshot, the first thing the snapshot's going to do is freeze all of your blocks that make up your files. So they cannot be deleted, they cannot be modified. It preserves the state of your files, that state, so that you can revert back later. Then what our snapshot feature does is if you want to make changes to a file, modify the blocks, rather than modify the blocks, it will redirect those writes to the snapshot. So let's say I want to modify blocks A, B, C because I'm changing the file. Those modifications are redirected to the snapshot. They're written in the snapshot. Then the file system is told to read the blocks, to read these blocks, the blocks from the snapshot, blocks from the volume. The file system is told this is your file now. That's the updated file. But let's say you want to revert your file to a previous state. All you have to do is tell your file system that this is the file now. You just tell your file system, read the file from the original blocks. If you read the file from the original blocks, you have just restored the file to the state it was in at the time the snapshot was taken. So first of all, this is very space efficient because you only have to save the modified blocks to the snapshot. Where with a complete backup, you have to save everything. And in most cases, it is a small percentage of the blocks that actually get modified, so very space efficient. The other thing is it makes the recovery time very fast. With a complete backup, you would have to just copy all those blocks back on, copy back everything. That takes a long time. But with Snapshot, it's only the blocks that were modified that have to be restored. And actually, I don't even have to copy back these modified blocks. I'm not copying back the original A, B, and C. I'm not copying and moving those blocks. All I'm doing when I revert the snapshot is I'm telling the file system to open the file from the original blocks. So before I revert, I open the file from these blocks. All I have to do to revert the snapshot is tell the file system, open the file from these blocks. So I'm not copying blocks, I'm not moving blocks, I'm just changing the metadata to tell my file system, open the file from the original blocks. So I don't even have to copy back the modified blocks. I just change the metadata. So this makes recovery time very fast, much, much faster than recovering from a complete backup. So our snapshots are very space efficient, but I still want to talk a little bit about what kind of activity will cause snapshots to grow in size and what kind of activity will keep your snapshots very small. So a good thing to understand here is that only modified blocks of data are saved to the snapshot. So activity that causes many blocks to be modified is what will cause snapshots to grow. Activity that does not cause many blocks to be modified will keep the snapshots small. So overwrites of blocks happen when files are deleted and then new data is written in to the same location. So it is deleting files that would typically result in the larger snapshots. The biggest way to grow snapshots is deleting lots of files. You may not see the snapshot grow at the moment you delete the files, but if you delete files and the next time you write to the NAS, there's a good chance you'll write to the same location that those files used to be, and then the snapshot will grow because those blocks where the file used to be then get overwritten. So it is deleting files that are the #1 thing that makes snapshots grow. But you may not see snapshots grow in the moment you delete the files, but still that's what will make the snapshots grow. The other thing that makes snapshots grow is modifying files, specifically modifying the blocks that make up the files. So most modifications are small and don't take up much space. Just a few blocks get modified. But if you were to do major modifications to lots of files, then if it's major modifications, that could cause more blocks to be overwritten. So large modifications to files and deletions of files are what makes snapshots grow. But on the other hand, if all you do is just add files, you can add file after file after file, even terabytes, terabyte after terabyte after terabyte. If you're just adding files, adding terabytes, that does not necessarily result in any of the other blocks being overwritten. So you can add file after file, terabyte after terabyte, and the snapshot still might be really small. So because snapshots are so space efficient, they are great for protecting you from ransomware. Typically with full backups, because they take up so much space, you might take one backup a day. So if you get ransomware, you might have to restore from yesterday's backup, lose a whole day of work. The other thing with full backups is that maybe it takes a whole day to restore that backup. So first you lose a day by restoring yesterday's backup, then you lose another day from it taking a full day maybe to restore that backup. Maybe you lose 2 days of work. But with Snapshot, maybe you take a snapshot every hour. And therefore, maybe you only need to lose an hour of work from going back to an hour ago. Let's say it takes a half hour to revert that snapshot. So maybe you lose an hour and a half of work with snapshots as opposed to losing 2 days of work with backups. And that's the advantage of snapshots. Snapshots are not a backup. A snapshot is a record of your system image at a point in time that allows you to revert back to that point in time. And they're very space efficient and they give you a very fast recovery time. But one thing I do want to mention is that our snapshots work better when you have at least 4 gigs of RAM. With just 1 gig of RAM, your maximum number of snapshots per volume is 16. But when you have 4 gigs of RAM, you can do the full 256 snapshots per volume. And so basically we had a choice. We could have chosen pure copy on write, or we could have chosen redirect on write. The advantage of redirect on write is it gives you a faster recovery time. The small disadvantage is you need a little bit more RAM. And so what we figured is that needing 4 gigs of RAM was a small price to pay to have a faster recovery time, because for most businesses, you might lose a lot of money if the recovery time takes a long time. So what we did is we chose redirect on write for the fast recovery time at the cost of needing 4 gigabytes of RAM. And I think most businesses would say that that's worth it, but that's the choice that we made. So let's just get into how you take a snapshot. It's really easy. I'm just going to demo this. So you go to Storage and Snapshots. You can go there just from right here, Storage and Snapshots. And then you just click on your volume. So let's say I want to take a snapshot on this volume. Click on Snapshot, Snapshot Manager. And then from here, I can enable a schedule. And you can take a snapshot monthly, weekly, daily, hourly, or repeat even just every 5 minutes if you want. So it just takes a few seconds to take a snapshot, so you can take them very often. And that can offer you very good protection. It's a very nice feature. It's very easy, up to every 5 minutes. And then if you want to restore from a snapshot, it's very simple. Click your volume. From here, you can see all the snapshots you've taken. Just click right here. Here I can see all my different snapshots. So I can revert to any of these snapshots. My options are to revert the whole volume, or I can click just one folder or even one file, and I can revert just that folder or revert just that file, or I can restore that file and folder to another location. So it's very simple, very easy. Also, from File Station, we now have a snapshot folder in File Station, and from there you can select any of your previous versions and revert there to make that very convenient. So let's go a little bit into space allocation. QNAP has chosen to have out-of-volume snapshots. That's opposed to in-volume snapshots. We chose out-of-volume snapshots for two reasons. One is the snapshot's more protected. It's harder for the snapshot to get corrupted if it's outside of the volume. That offers protection. Also, you have a lot more control of how much space that snapshot uses. So let me give you an example of, let's say you had in-volume snapshots. That means snapshots take the space from your volume. And often this can be confusing for IT managers because the space that snapshots take is often hidden. You often can't see how much space they're taking. So let's say you figured out that you need 5 terabytes of space in your volume for all your backup jobs just to ensure that they all happen. So you make your 5 terabyte volume. You think you're fine. Then over time, maybe you do certain activity that causes your snapshots to grow more than expected. And now all of a sudden, you don't have all that space for your backups. And you could find that your snapshots might take the rest of your remaining space. And now there's no space for your backups. Your backup jobs fail. And this can creep up on you. The advantage of out-of-volume snapshots is that if you have a 5 terabyte volume, your snapshots can't take any of that space from your volume. So if you need to reserve 5 terabytes for your backup jobs, just reserve that space. And if you have a 5 terabyte thick volume, your snapshots can't take any of that space. So the advantage we have about a snapshot volume is you can easily see how much space is used, control a lot better how much space is used. Multiple volumes and lens can share the same snapshot space. So it's a very good feature. Now, since your snapshots are out of volume, they reside in the free space. So they can take any free space that's not used by your volumes or lens. However, since volumes and lens sometimes grow in size, we didn't want snapshots to be able to stop your volumes and lens from growing. So your snapshots can use free space until your volumes and lens need it. Then as soon as your volumes and lens want that free space, they just take it, and they can take it right from the snapshot. Your volumes and lens get priority over free space. However, we have something called snapshot reserve space. And that with snapshot reserve space, that space is dedicated just for your snapshot. Nothing else can use it. So snapshot reserve space is reserved for your snapshots, but like thick volume space is reserved just for your volumes. And just so that space isn't wasted, any free space that's not used by anything else, your snapshots can also use that until something else needs it. So that we have very good control over how much is reserved for snapshots, very good control over how much is reserved for your volumes, lens, whatever. The downside of this, though, is that often if there's a new user who doesn't know any better, a problem that they had was maybe they immediately make a volume and set the size to max so that there is no free space for your snapshots and you can't take snapshots. So this was a problem we ran into. So first of all, with QTS 4.3.4, we dealt with this problem by giving you the ability to convert a thick LUN or thick volume into a thin LUN or thin volume to free up space. So then you can take snapshots, you can make other volumes and LUNs because you freed up space, and that was great. But some people don't want to convert to thin. Some people want thick. So now with QTS 4.3.5, we have the ability to shrink a thick or thin LUN. So you can shrink your volume, shrink your LUN to free up space. So we think the best practice for snapshots is separate your system volume from your snapshots, have out of volume snapshots, which is what we have done. Also, when using thick volumes, it's good to reserve space in advance for your snapshots. And when space is insufficient, you can reduce the size of your thick volume, or you can convert it to a thin volume. Also, using Snapshot Replica, you can store even more snapshots. Another change we have made to our snapshot feature with QTS 4.3.5 is that we can now take a snapshot of your cache. So it used to be in the past that before taking a snapshot, you used to first have to flush your data from your cache to your spinning disk, then you could take the snapshot. That just made the snapshot take a little bit longer when you had cache. But now you can take a snapshot directly of your cache and your spinning disk at the same time. You don't have to flush your cache first. So cache doesn't need to slow down your snapshots nearly as much. And so you want to have a snapshot every 5 minutes, that's no problem. Snapshots happen really fast, just a few seconds. And cache doesn't have to significantly slow down your snapshots anymore. Another feature we've added is we have integrated snapshots with Windows previous versions. So if you, let's say, map a folder onto your Windows through SMB or whatever, you can just use Windows previous versions to access the previous versions of your snapshot. Just makes it more convenient. Another feature we've had for a while now, this isn't that new, but for a while now we've had the ability to have a snapshot share folder. And what that is it makes a folder that's its own LUN that you take snapshots of. What we have found is that reverting a snapshot of, say, a 300 gigabyte snapshot folder is faster than, say, reverting a 300 gigabyte folder that's within a larger volume. So that can just make the restoring a little bit faster to make a snapshot share folder. Another feature that's not really new, but it's worth mentioning, is we have Snapshot Agent. This is if you're using like Virtualization Station, Hyper-V, something like that. What Snapshot Agent does is it tells like your VMware server, Hyper-V server, whatever, it tells your server, I'm about to take a snapshot, so please flush the data from your RAM to the LUN. This is important because we can't take a snapshot of something that's in the RAM of your VMware server. So for the sake of integrity, it's important, tell your VMware server, flush the data from the RAM to the LUN, then take the snapshot. So this just ensures integrity. So let's talk a little bit about Snapshot Replica. So I often like to say that Snapshot is not a backup. Snapshot is versioning. However, Snapshot Replica is a backup plus versioning. So Snapshot is versioning, Snapshot Replica is backup plus versioning. And that means that first Snapshot Replica is a complete backup. And then from then on, you only need to replicate the changes. So the first backup's a big backup. After that is very space efficient, doesn't take much bandwidth because it just changes after that. And now we have integrated Snapshot Replica with Snapshot Vault so that you can revert the whole volumes through Snapshot Replica or just restore a specific folder or file. And also we've given you the ability to clone a Snapshot Replica. So to set up Snapshot Replica is really easy. Go to Storage and Snapshot, Snapshot Replica, create a job, use the wizard to find a suitable remote NAS, and set up a backup job. So you can set Snapshot Replica to happen on a schedule. You could also have it happen whenever you take a local snapshot. You can do Snapshot Replica through 10G, not just single G. That makes the replica happen faster. You can also restore from your replica faster when it's through 10G. And because of how well we've integrated it with your Snapshot Vault, um, you don't have to just revert the whole volume. In the past, it used to be that to restore from the Snapshot Replica, you used to have to revert the whole volume. But that might take some time. And let's say you just screwed up one file. You deleted a file, you made a change you wish you didn't make. You don't want to revert the whole volume. So now you can revert just a specific folder or even a specific file. That happens much faster, much more convenient. And that's kind of what we've newly added to Snapshot Replica, is the ability to restore just a specific file or folder. So just select the folder you want to restore, or you can clone. You have different options: revert volume, you can clone, or restore a specific file or folder. And another feature that we've just added, which I think is great, is the ability to export a snapshot replica to an external device, let's say an external hard drive. This is really good because that first snapshot replica is a complete backup. And so that's big, right? And a lot of customers found it problematic to send terabytes of data through the internet to your offsite NAS for your snapshot replica. And so what customers used to do is bring that offsite NAS, they bring it on-site for that first snapshot replica job, then ship it off-site. And then they only need to replicate the changes through the internet. But that was kind of a pain, right? So now you can just export the snapshot replica to external hard drive. Then you can ship that external hard drive to your offsite NAS, and then you can import it from that hard drive to the offsite NAS. And then from then on, you just send the changes through the internet. This is a similar concept to, say, like an Amazon Snowball. And it's just a really convenient feature when you have terabytes of data you want to move for that first snapshot replica to move that offsite. And then from then on, you just replicate the changes. This is a very helpful feature. I'm very glad we added it. That's about it. For a recap, Snapshot takes much less space than a full backup. Snapshot offers a much faster recovery time. You can control the snapshot space because snapshots are outside of volume, and that protects your snapshots a lot better. And cache doesn't need to slow your snapshots down much like it did before, because you can take a snapshot of the cache, and you can export a snapshot replica, so that first replica to an offsite NAS is no longer problematic. So we've already had a very good snapshot feature, but we've just added some new features that I think have made it even better. So I hope that's helpful. Thank you for watching.